Hi everyone. Today's lesson is on dividing rational expressions. And so the example that you see on the paper is 2m squared minus 8m plus 6 over 5m minus 5 divided by 6m squared minus 8m plus 2 over 15m squared minus 20m plus 5. Now that's a mouthful. What we're going to do is take it one step at a time, and just like when you first learned how to divide fractions in elementary school, we're going to keep, change, flip your problem here. So what that means is we are going to keep the first fraction just like it is. We are going to change the division to a multiplication, and then we're going to flip the second fraction. Now I'm going to do that before I try to break any of the numerators or denominators down, just simply to get that out of the way. And it's easy to forget to keep, change, flip. A lot of times people want to just go ahead and start factoring and canceling out, but they forget to flip the second fraction and to change the division and multiplication. And so we're going to do this first and get that out of the way. So now the second fraction has the numerator 15m squared minus 20m plus 5, and the denominator 6m squared minus 8m plus 2. So now what we're going to do is factor each numerator and denominator. Well, if you look at the numerator of your first fraction, all of those numbers are even, and so I know I can take a 2 out, a greatest common factor of 2. That's going to leave me m to the second minus 4m plus 3. Now, that 2 is still part of the answer. I don't just get rid of it, even though I divided all three terms by 2, and this is what we got. We still have a trinomial left that is possibly going to be factored again. So we'll look at that in the next step. Now what we're going to do is look at the denominator. Well, that's a binomial, and I notice that there's 5 in both terms, so I'm going to take a 5 out. I'm going to use a greatest common factor of 5, and then that's going to factor into m minus 1, because 5m divided by 5 is just m, and 5, or negative 5 divided by 5 is negative 1. I'm going to do the same thing in the second fraction. If you look, you have a 15, a 20, and a 5. Well, I know that 5 goes into all three of those terms. So I'm going to take a 5 out. I don't take out any variables because 5 on the end here does not have a variable. So I can only take out a number. So I'm going to take 15m squared and divide that by 5. That's going to be 3m squared. 20m divided by 5, or negative 20m divided by 5 is going to be negative 4m. And then 5 divided by 5 is 1. The denominator of your second fraction can also have a greatest common factor taken out, and that is going to be another 2. Okay, so 6m squared divided by 2 is 3m squared. Negative 8m divided by 2 is negative 4m. Made a mistake there. And then 2 divided by 2 is 1. Now, I want you to look at your entire problem. We can possibly factor this one more time. This is pretty much factored. But look at this. You end up with the same thing in the top that you also have in the bottom. This entire trinomial. So don't worry about trying to factor it. Go ahead and cancel those out. Those are now gone. Now, in addition to that, we have a 2 in the numerator here that we also see in the denominator here. We could go ahead and cancel those out. And in the same sense, we have a 5 in the numerator here that we also have in the denominator here. So we could go ahead and cancel those out. Well, that takes a lot of your problem away. And so now what we have is m squared minus 4m plus 3 all over m minus 1. So now is where I'm going to look at possibly factoring this one more time. It's a trinomial, so I'm going to use a t-chart. And remember, we use b, so negative 4 is going to go on this side. And we do a times c for this side. So 1 times 3 is 3. Well, the only factors of 3 are 1 and 3. And I know if I add 1 to 3, I get 4. But remember, that's a negative 4. So we need to make both of these numbers negative. And if we multiply negative 1 times negative 3, we do get positive 3. So the top is now going to factor into m minus 1 times m minus 3. All of that is going to be over m minus 1. So now we see that we have an m minus 1 and an m minus 1 in the numerator and denominator. We can cancel all of that, and your final answer is going to be m minus 3. So it turns into a multiplication problem in the very first step, okay? And then it's just business as usual, factor and cancel. Again, if you can cancel some stuff out before you get into all the second step factoring, then do that and make it easier on yourself. The other example that I want to show you is called a complex fraction. It's going to look scary, but it's not. We're going to turn it into a problem that we just did. So we've got x minus 1 over x plus 3, but then you see this giant fraction bar, and then you see another fraction. 5x over x squared minus 3x minus 18. So basically, this is called a complex fraction because you have one fraction divided by another fraction. So what I'm going to do is just kind of make some notes. Okay, this is one fraction, this is the division symbol, and this is another fraction. What I'm going to do is rewrite this so that it looks like the other problem. So I'm going to recopy x minus 1 over x plus 3 divided by, and then 5x over x squared minus 3x minus 18. Now it looks like the problem we just did. So what we want to do again is keep, change, flip. So we're going to keep x minus 1 over x plus 3. We're going to change that division to multiplication, and now we're going to flip the second fraction so that x squared minus 3x minus 18 is on the top and 5x is on the bottom. Well, I like this problem because x minus 1, x plus 3, and 5x are already simplified. We only have one part to factor, and that's going to be this second numerator. So again, we're going to use a t-chart. We're looking at negative 3 is b, and then we're going to do a times c. So 1 times negative 18 is negative 18. So we're going to find all the factors of 18. I know 1 times 18, 2 times 9, and 3 times 6. Now, because 18 is negative, one number in each pair has to be negative, and the bigger number is always going to follow whatever b is. So that means that 18 would be negative, 9 will be negative, and 6 will be negative. So when I look at which pair can I add or subtract to give me negative 3, it's going to be this last pair, 3 plus negative 6. So when we factor that numerator, it's going to factor into x plus 3 times x minus 6. Okay, do you see anything in the top that you also see at the bottom? And you do. The x plus 3's cancel out. And that's all that we can do. Now what happens is you have an x minus 1 and an x minus 6 in the numerator. So we're just going to write those side by side. We do not have to multiply them back out. So I'm just going to write them side by side like that. And all we have left in the denominator is 5x. So this is your final answer for that really hard-looking complex problem. Okay, so the assignment that I have for you is very similar, okay? So the first few examples, or the first few problems, you're going to keep, change, flip, but you don't have to really factor anything. You're just reducing. Same thing here. But when you get into number 3, that's where you're going to be able to factor some stuff right here. But remember, you want to change that division to multiplication and flip this fraction before you do that. Same thing with this one. You'll be able to factor both parts here. And then when you get down to 9 and 10, those are like the second example that I just showed you. So you'll want to rewrite it first. This is your big division bar, and this is your big division bar. So it's this fraction divided by this fraction divided by this fraction. Rewrite it like I did in the second example, from here to here. Then do your keep, change, flip, factor, and cancel.